Welcome to Carbide 3D Education. I'm Kevin Barnett, and welcome to Carbide 3D. In choosing us for your CNC manufacturer and purchasing a machine from our company, you have acquired much more than just a capable machine. You have acquired the best partner in the industry. Everything we do is designed to have you have success with your machine. You'll find we have information, ideas, and inspiration on our YouTube channel, through our Instagram, as well as through our educational series. We have my.carbide3d.com that provides a tremendous amount of very specific learning opportunities for you to educate yourself about CNC. We're glad you're here. We want you to look forward to going out and using your machine and harnessing the tremendous power that you now have. This is primary school, designed to get you up and running from zero. From, hey, I just bought a machine, I haven't done CAD or CAM or operated a machine before. We're going to get you started and we're going to make you capable. You're going to have success, but there will also be firewood. Mistakes are part of the process. Okay, a few things as we get started. CAD, computer-aided drawing or drafting, CAM, computer-aided machining, and actually running the machine itself are three areas we're going to touch on frequently. The relationship between those three things can be complex. They have lots of touch points, and changing one thing here might affect something else down the road in one of the other systems. However, none of it is complicated. Do not think this is something that's unapproachable that you cannot learn. And that goes for the nomenclature too. The words, the terms, the ideas. You're going to have to just let it flow. And we're going to give you contextual examples, things to build, stuff to do, so that you learn over time during the process. Much like playing a hand of cards, I can explain to you how to play a particular card game in words. Doesn't make a lot of sense until you actually play the card game, and then you go, okay, I understand, no problem, that was super simple. That's how this goes. So we're going to have computer sections, and we're going to have a little bit of advice from me, some contextual information. We're going to teach you a ton of concepts through these three projects. Watch the 3 CAD CAM videos and run the project on your machine with the accompanying machining video. Let's set about establishing concepts and habits that will benefit you throughout your CNC journey. This is going to be primary school video number 1, the CAD CAM of a drop tray. And a drop tray is a fairly simple item, but it can be taken next level as you acquire skills throughout your CNC learning. We begin in the computer inside Carbide Create, and you might see a couple of extra buttons up top here. I have the model tab because I have the pro version of the software. There'll be a couple of extra tools in there as well. We're not going to do anything in these first 3 videos that require Pro. There's so much you can do with just Carbide Create, our provided and included CAD and CAM software. All right, let's dive back in here. We'll go to our design tab that is in the upper left. And the first thing you want to do is get onto your job setup. If you hover your mouse over the icons, you will get the tool. It'll show you exactly what the tool is. Remember, this is a contextual program. As you click on different things that you've created inside of Carbide Create, you're going to get different options. First thing, job setup. All right, we look at our job setup and up pops this menu here. This is your first visit when you're starting a project. You have to know how big your stock is. This brings me to tools I keep at my desk, and there are 2 critical ones. First, a tape measurer for measuring my stock. And this is in metric and imperial because I work in imperial for larger sizes and metric for smaller sizes. With those smaller sizes, a set of digital calipers is critical. Just buy yourself a pair. Actually, get a couple. I have 1 pair at my desk where I design most things, and I have 1 pair down by the machine where I definitely need them as well. They're inexpensive, super simple to use. There's lots of different ways to use them. Go ahead and educate yourself on how to do that. Again, kind of over time, you'll learn these things. And now it's time to put those tools to work. We have to get our stock size exactly dialed in. Now, what to use for a first project for a drop tray? A lot of people, I think, right away go to pine. They're inexperienced. They don't want to waste a lot of money. Pine is where they head. Pine is not awesome for machining. It's okay. You can use it. It's fine for testing, and it might even be okay for this project. I'd like to make a different suggestion, and that is poplar. Poplar is not much more expensive than pine, and particularly if you go to a wood shop, you're going to find yourself a nice piece of poplar, and this is going to machine a lot cleaner than pine. It has a little bit different cellular structure, Pine has big, wide grain, it has big, wide cellulose kind of parts where you're going to cut through and it's going to disintegrate. Doesn't really take detail that well. This, on the other hand, does take detail quite well. And understanding the resolution of your stock is important. We have a video on that. You might want to check that one out later. So I have this big piece of poplar that I want to use for the drop tray. So let's take a few measurements. Again, back to the measuring tape. So let's grab a couple measurements here. 9 1/4 roughly, and this is where I like millimeters because millimeters are so tiny you can get an exact number, but it's not critical. And then we can take just some length, right? We're going to throw this in the machine. I'm going to say we have 20 inches right now, and I'm just going to throw that in the machine so I have a piece of stock. So that was 20 by what? 9 1/4? What do they say? Measure twice, cut once. 9 1/4 by 20. So let me go ahead and throw that in. With 20 inches, height 9.25. All right, we have those two measurements in the computer. Next comes the most important measurement. People get all worried about digging their end mill into the bed of their machine. Listen, here's how you're going to actually prevent that from happening a majority of the time. The calipers. Time to use the calipers. And now here, I'm going to actually enter something in millimeters and show you right away that you can work in both units at once. So let's take a couple measurements here. And with any hardwood, particularly from a big box store, you want to kind of take an aggregate measurement. So 20.8 millimeters, 20.68 millimeters, 20.5. All right, so we have these little tiny variations. Take one more. Yeah, 20.5. So I'm going to go with a 20.6 millimeters. 0.1 of a millimeter is not going to make a big difference. Now watch this. We're working in inches in our file. 20.6 mm, the equals key, and it goes right to inches. It will automatically convert it. And you can do this with inches or with millimeters throughout the program. So don't worry if you end up with some sort of material that's only measured in metric or only measured in imperial and you're working in the opposite unit of measure. You can go ahead and enter it like that. Just mm or in, hit equals, automatic conversion done for you inside Create. So thickness 0.811. Next up, material. You can choose this material. This is kind of just a reminder for you. Hardwood. It's not really a hardwood, it's kind of a softwood. So we can choose that, softwood. And then machine, Shapeoko 5 Pro is what I'm going to be using. And then retract height. Okay, here is where you can save yourself some time, is on the retract height. I like mine at 3 millimeters. That's my preferred height. So 3 mm equals, and it's 0.1181. You can tell I've been in this program earlier. So that is my preferred retract height. For the sake of imperial, you could just go with 0.12 of an inch. That to me is high enough that it's not going to touch generally. But if you are working with large sheets where you don't have the middle of your sheet necessarily pinned down, you're just doing some cutouts and stuff, not some intricate pocket work, you might want to go ahead and raise that retract height a little bit, because otherwise if you don't come up high enough, when you're rapiding, that is going between cuts, you may drag the end mill across your material. So project by project, choose that. For 99% of my projects, I go 3 millimeters, but I'm pretty diligent with my work holding, and you probably will be too over time. All right, 0.12 of an inch for our retract height. That's going to be a good height, and I'll hit OK, and right away our stock drops into Carbide Create. So let's get back to designing, shall we? And when you're designing things here, particular drop tray, I like to lay out the outside first. And I'm just going to drag what I think is a reasonably sized drop tray and something that'll fit within my stock. And I have a sheet here, let's see, maybe 14 inches wide, let's try that, by 6 tall. And we'll start with that dimension, we'll see how it goes. I might want to be a little taller actually. Let's go 8. And I do a lot of this visually, right? 8 now is too high, so 7. So I like to do this visually and just take a look at, okay, let me look at my stock next to my position, let me look at my stock laid out in here, and let me decide how I think the part is going to come together. Here we're just going to use one end mill, so we need to plan accordingly. Our first project is going to be with that 201 3 flute end mill 1/4 inch that you got with your machine. Easy to use, super capable. Now on our squares, any rectangles you drag, that is off the tool menu here, the create vector menu, you are going to have some options to go with that. So when you drag it, you will then see it sized and you can alter some things about this particular rectangle. Let's go back and click on our rectangle and we still have our 14 by 7 rectangle. The corners, you have several options in the corners. Square is just, yeah, a dead point, 90 degrees. Fillet, and you can change the fillet size. Again, you can alter it however you like. You can be 0.5, 0.35, whatever you would like to do. Here, I think 0.35, that looks pretty nice for a fillet. What if it was a chamfer? Well, we have a 0.35 inch chamfer. You can just go with a hard angle. You can go with a flip fillet, dog bone. Dog bone's useful for certain items. Or a T. Yeah. There are reasons why you might want a T, but we don't. Let's go in and go with fillet for now. So we have a nice radius on the outside, sharp corners on the outside of items, not so much fun. All right, so we have our basic outline. Now here is where you have to decide what the drop tray is for. And if you wonder, hey, is this really a usable item? Why am I making a drop tray? Hey, I have drop trays all over the place. This one is a rather unique one. It lives over on the foot of my desk, or the corner of my desk surrounding the foot of my monitor stand. I have a bunch of other drop trays at home. I have a Michael Jordan drop tray that I've made that I really like. A drop tray, while seemingly completely ordinary, can be totally unique, custom. You can add all sorts of sweet features to it later as you progress down your CNC journey. Here we're going to give you a basic one. Once you master the form, you can really start to explore what you can do with different materials and different methods. All right, so we have this, and what are we going to put in the drop tray? We've got an older phone here. I'm going to go ahead and drag, and we'll get some measurements off the phone here. I'm going to measure that, and this is where I think millimeters are better, but they don't have to be. 6 1/4 would get it done. It would be so tight. Why don't we go, yeah, see, you get into eighths, and if you're comfortable with eighths and thous and things, okay, fine, whatever you want to do there. 165 millimeters for a length. So let's go ahead and make ourselves another rectangle. And I'm going to make it with 165 equals. And how about the height? Here we can get a measurement with the calipers, and we can go a little bit over. All right, 80 equals. So 3.14 inches, 3.15. You can always reduce these fractions, just round up if you're working in the alternate scenario. So there's our phone laid out, and I'm going to do it this way rather than vertically, just to save some space in the tray. So we take our phone and we throw it down there. Let's look at what else I have on my desk that I might want to organize in this case, because as long as I'm making an item, I may as well make something that's useful, right? Measure that, and this is why you want to have calipers around, man. You want to measure with calipers. 1.25. There we go. And there we have that remote. I'll throw that in there. Remember, we're cutting with a 1/4 inch cutter, so you cannot get absolutely pointed turns when it's on the inside. On the outside, you could. If you went around a corner with a cutter, you could accomplish that. If you go inside, you're limited to the diameter of that cutter. So why don't we go ahead and fillet these, and we'll go 0.25. We'll just tell it exactly what we're using here, so we know what we're going to get. And we might want to oversize this just a little bit more. 1.27 by, we'll just go 5. So we oversize that a little bit. Let's oversize this one a little bit. You don't want to get too exact. You can definitely get too exact when you're making some projects here. 6. All right, that'll have a little bit of room so that you can have some slop in there. So we have our phone, we have a remote. What else do I want to throw in there? We've got some room. How about this set of glasses? 2.5 inches. We need to make another rectangle. We'll go 2.5 wide, 6 inches long. And we'll take this guy and we'll throw him in here into our tray. We're going to fillet those edges as well. 0.25. And our drop tray is starting to take shape. All right, we've got a spot for one more pocketed area. Let's just throw in something for junk, shall we? Everyone has junk at home, right? Let's put in a shape. I'm going to use the alignment tools here in just a second. We'll go ahead and make it a fillet. 0.25 is fine. All right, as far as positioning for everything that we have in here, we now can use the alignment tools. And there are a couple different things you can use. The alignment, you can align to the stock at any time, and this is our alignment tool here on the left, align vectors. If you have one vector selected, you will be aligning to the stock, and you can see that as the only option in the align reference. If you have two vectors selected, remember that the second vector, whatever vector is in a dotted line, is what you're going to align to. So right now with one selected, I have a dotted line on my only vector selected. That would be aligned to the stock. If I hold down the Shift key and collect our outer outline, now that is the dotted outline. So any movement I make, any alignment that I ask for, it's going to move this first vector, the solid vector, and keep the dotted vector stationary. With the dotted vector stationary, we can align to it, let's say in a vertical. And you see here, align to last selection, the dotted line. So it'll tell you, it'll remind you what you are about to do. Go ahead and hit that, and now we've aligned vertically. It is dead center. If I wanted to put it right in the middle, I could also do it this way, and it would be in the middle of my part. This gives me a chance to show you Command Z. This is your best friend, Command Z. Just like a lot of other programs, you can undo what you just did. Command Z and Command Shift Z if you're in the Mac operating system, or Control Z, Control Shift Z to go forward or backward, undo, redo. Super handy when you're trying to design stuff. Make sure you use it. All right, so we have that there. Let's go ahead, and now that this is in the middle, we could actually align this to that if we wanted. So why don't we go ahead and tell it vertical, and it was just about there anyway. How about these guys? We want these guys aligned to one another, and we want them aligned to the inside edge of one another, let's say. So there, we got a tiny bit of movement. Let me show you a little bit of movement there. So if this was over here, and this guy was in the position that we wanted him in, why don't we hold down Shift? We could say align inner edge, and it would pull, remember the not dotted line, the solid line to the dotted line. And that's not what I wanted. I had them selected in reverse order. Command Z. Let's reverse the selection order here. Let's go ahead and select our last vector here. We're going to align to it. And now we pull that smaller vector to the left. You have lots of options for manual movement when it comes to parts of your tray. You can have snap to grid on, where you can grab a node, and you can utilize the snapping to the grid to position within your grid size exactly where you would like your vectors to be. And the grid size can be altered with no vectors selected. I can go over here to the grid on the top, and it says set grid. It is right now at 0.15 of an inch. If I want to go 0.25, a quarter inch, hit OK, and you notice how that alters the grid. We did not change the size of our stock, but we did change the size of our grid. So now you can actually highlight all of your vectors, and we can grab them and put them onto a particular part of our stock. And then we can go in, and we could grab these two vectors, again holding the Shift key, and we could position it there 2 squares from the side. So now I know with a quarter inch that I am 1/2 of an inch from the edge of my tray. And visually 1/2 of an inch, this is why you keep this on your desk, this is why you keep this on your desk, is to get yourself acquainted with, hey, is a 1/2 an inch how much I want, how much space I want to leave when it comes to this particular design. I'm a very visual person. I like to have the visual aids with me at the desk. That's why I have all of these tools here as well as down at my machine, since for many of you, like here at HQ, that might be 2 different positions. Let's use the alignment tools to move everything around. And now let's grab all of our inner portions. We're going to group these. When you group items, they start to behave as one item. So with all these items grouped, now what I can do is I can select the outer outline of my tray with the final selection, and you notice that is dotted and all the interior ones are in solid. I can go ahead and hit center, center. This is align centers. And it will position those items as though they were one block into the center of our stock. If we didn't have it grouped, here's what would happen. Let me go ahead and ungroup here. What if these weren't grouped? I selected everything. Our dotted line is the outside edge, just as we had hoped. Let's go ahead and hit center, center. Yeah, not what we wanted. Command Z, we undo that. We can go ahead and slide over. After you get them aligned, you don't need them grouped. But if these were out here, and we select it here, and we told it to align center, center, it will bring them right back. Okay, we have all of our pockets set. And this has taken a little while because it's the first time. It's the first project. To make a drop tray, quickly measure some stuff, go ahead and throw down some pockets. You can rep these things right out. They're really fun to give to people as just little presents, and it's good practice for you. I love a drop tray as a present. Now it's time for the CAM. This is computer-aided machining. This is where you're going to assign the tools to the tool paths. Here we're going to have one tool, but we're going to have different depths for everything that we're putting in our drop tray. Before we dive in, let's talk about the different tool paths that you have available. Contour, Pocket, Texture, Drill, V-Carve, and Advanced V-Carve are all included in the basic version of Carbide Create. We're going to get into V-Carve and Advanced V-Carve in our upcoming videos. Right now, we're all about contours and pockets. If you want to dive into each one of these toolpaths specifically by themselves, we have tons of great information on my.carbide3d.com, our learning platform. There you can find just about anything you want in granular detail. So let's take a look at what we want to do here. For each one of our vectors, we want to ungroup them so we can select them individually. We would like to set a different depth depending upon the item that we're planning on throwing in that portion of the tray. When it comes to the phone, 0.4 of an inch. This was 0.332. Let's go 0.4 of an inch. So we select our contour, and we're going to go pocket for our very first toolpath. We're going to use our current selection. Select by layer, very useful. We're going to use that in a later video. For now, we want to tell it what cutter we have. The default is in there. We will select our tool. This is the pre-populated library from Carbide Create and Carbide 3D for the materials as well as your machine. So if you're working with a Shapeoko, aluminum, hard plastic, hard wood, soft plastic, soft wood, these are really conservative feeds and speeds. You're going to have success with them. They're going to cut. They're not ideal. You could definitely speed up. If you go too fast with the smaller cutters, you might break them, but you're going to learn this along the way. Broken cutters and firewood, totally normal. Okay, that's part of learning how to machine things. Let me give you a little detail about the settings within each tool. Feed rate is the rate at which the cutter is being pushed in X or Y through your material, and the speed is the spin rate of your end mill as it's pushed with the feed rate through the material. Your depth of cut is how deep each individual step down is going to be each time it goes to cut a level of your pocket or of your contour. The plunge rate is how quickly the end mill is moved vertically for the next depth per pass or depth of cut. Now your step over is how far in X and Y will your cutter be moved when it goes to cut another path. In a pocketing toolpath, there are multiple step overs to achieve a certain depth in the entire pocket. These are the basic settings. They're all pre-populated, and you can use those as they are. You will learn to change them just a little bit. It'll take time, but start with the stock settings. You'll see when we get to machining the little alterations we make. We're going to use softwood here. We're going to use end mills. The 201 is our end mill. And we're just going to pull it out of the list and hit OK. And I'm going to leave these parameters as is. I'm not going to alter them at all. We'll go with the stock parameters. And then we'll tell it how deep we want it to be. 0.4 of an inch is what we said. So it's going to go from the top of our stock down to 0.4 of an inch. And ramping and rest machining, these are pro features. You won't see these unless you have the pro version of the software. Ramping, particularly useful when you're cutting hardwoods and metals. Rest machining, that's useful when you're doing large things that require large cutters to remove a bunch of material, and then you just want to go back and do the details. I think Carbide Create Pro is pretty compelling. We have other videos on that. It's up to you. You can also make darn near anything with Carbide Create A little more time, a little more creativity on your end. You don't have to have the pro version of the software. But if you're opting in, 10 bucks a month, compelling. All right, then we'll call this phone pocket. And you want to develop these habits right now. Name your toolpaths, name your toolpathing groups, because as your program complexity grows, you're going to want to know what portion of my cut am I in? What geometry am I actually operating in? The more you name stuff, the more you change the names and put them into your regular workflow so you know, hey, this is generally how I organize it, the better. All right, phone pocket. And now you see how everything widened out. We have the 1/4-inch cutter. It's going to take 14 minutes at the stock settings. We're going to speed them up at the machine a little bit. Let's go to our next pocket, and we'll just call that a pocket. Use current selection. We've got the 201 pre-populated in. We're going to be putting in our remote control. It's just this little guy, so we want a tiny little space for him. He's about 0.2 thick. Why don't we leave a little lip? 0.125. And this is our Apple TV remote pocket. Bang, done. How about this pocket here? This was for the glasses. Wait, why don't we go ahead and show you how to duplicate a toolpath. Watch this. I've selected our new vector. I'm going to right click, duplicate toolpath. I can rename it. This one's going to be called glasses. Pocket. Use selected vectors. Leave that checked. Hit OK. And we now have all the settings from our previous cut pre-populated into the next cut and assigned to the new vector. We first have to select our next vector. Duplicate toolpath. We're going to call this random junk pocket. There we go. That was quick, wasn't it? Less entry, less time, just bang, bang, bang. And now it's time to say rename toolpath, and we're going to call this all pockets. And you right click to pull up that menu. Right click again, and you notice the options that we have here. Move up, move down, disable, delete. How about create new toolpath group? Let's do that. And let's rename this toolpath group. We're going to call this cutout. I like to keep my cutout separate just so it's on its own. I can disable that group pretty easily. I don't have to go through and find it wherever it may be at the end of a list. I can just disable this particular group if I need to change something in my program. You'll find that the ability to change something in your program is super handy. All right, cutout. For that, I want to select my outer contour of my design, and I want to go to contour. Use current selection. Now for a contour cutout, you're going to have to select a maximum depth. Do you remember what we measured when we measured exactly the depth of our stock? I don't by the time I've gotten to this point. You probably won't either. So rather than go and remeasure or back out to the design tab and look in job setup and write that number down and come back and go ahead and enter it again, here's what you can do. Just like we have the conversion between millimeters and inches as part of what's called our expression editor, another portion of that is the use of T, and T is for thickness. So if you put in the value of T, you're telling it, I want to cut to the thickness that I entered in the job setup at the very start of my program. So it knows whatever that number is, 0.68, whatever it was, 1.2517, whatever you put in, doesn't matter. T equals that number. So the machine will cut to that value. I'm going to use T. The offset direction. This is where the cutter is located on a contour. You can cut inside of a line, as it is with a pocket, inside of your vector. You can cut right on the vector, and there's reasons you would want to do that. You can cut outside the vector. Anytime you're making a cutout, you want to cut outside right, outside of our drawn vector. And stock to leave, don't worry about that. Direction, don't worry about that. Those are pro features. The offset direction will be there. The others will not. The stock to leave into direction. Ramping, not there. Tabs, always present, and you need to use them. Let's set our tab height. So our tab width and tab height. I like 3 millimeters for both. You might want to go 5 on your very first project. You might want to put in 5 millimeters to make those tabs a little bit stronger. Remember, whatever tabs you put in, you're going to have to cut off. So here, all I'm doing is defining the size of the tabs in the toolpath. We'll call this full cutout. We'll hit OK. Now you'll notice there are no tabs on my design. We said how big the tabs should be, but there are no tabs. Tabs are in a different place, and I often find myself going to the toolpathing first, then having to go back to the design. Back in the design, if you hover over in the edit, you'll see Edit Tabs. Click on Edit Tabs, and you can add tabs to your project. Now we've already defined how big they are, right? There they are. Now what if you want to take one away? You want to change where you have them. You simply click again on the same spot to remove them. I'll tell you, tabs in line with grain, that's pretty nice. They're a little easier to sand off versus cross grain. So I tend to try and put them in line with whatever it is that I'm cutting in terms of the grain of the wood. All right, we have 4 tabs on there. Hit OK. Without having to go into the toolpath again, it's already going to be updated. Those tabs are going to be accounted for. Let's go into our simulation. Now, you need to use simulation. Simulation is an important part of any successful CNC project. You want to see it in the computer before you see it in real life, because cutting poplar is a little more expensive than cutting pine, which is a little more expensive maybe than cutting MDF. Cutting virtual wood, free, $0. You can do it as many times as you want. And here we have actually a brand new feature where we will show you the toolpaths, the rapids, and you can actually watch it get done. Slow it down a little bit, hit play, and you can watch the cutter go round. Watch your virtual wood get cut. Here it comes in as aluminum first. Let's go to beech. We can get rid of the toolpaths and rapids if you know where it's going and you're okay with where it's going. And you can see we have a nice looking tray. Now, one thing you notice, the pocket for our Apple TV remote, we set that at a certain depth, right? I think it was 0.125 of an inch. We set a particular depth for the phone pocket. What we didn't do was go back in and set a depth for the glasses pocket or the random junk pocket. We just got the copied value from our previous toolpath. So now I've caught that in simulation and go, oh, I want these 2 pockets to be deeper. Let's go back. We go back to our glasses pocket, double click it. How deep do you want the glasses pocket to be? That's the question. Here's our glass case. Let's take an estimate. We'll go about halfway, 0.6. So we enter 0.6. We hit OK. Let's take a look at our simulation again. This time it cuts it to 0.6 thickness. A much deeper pocket. How about this next pocket? What do we want to alter that to? We know it's our 4th toolpath because we said here's the random junk toolpath. Double left click, double click, you'll go into edit. You don't have to right click edit operation. You can simply double left click and then decide. How about random junk? What do we want for random junk? I don't know, 0.35, how about? Hit OK. Show our simulation. Oh, we were still calculating. A little too quick. That looks better, doesn't it? Here's where you can also inspect your tabs. You can zoom in onto your tabs. Now, anyone working with just a trackpad, just one of these guys built into your computer, that's not the way to go. I'd go mouse, buttons, and wheel. You can zoom in, zoom out. Much more convenient right and left click. There's our tabs. Get a look at how durable our tabs are here. Zoom out, and there's our tray. We've made a tray. It's going to be sized right. Should be out of some poplar, decent material. That looks pretty good. I like it. All right, go ahead and hit Save, Control S. Call this poplar drop tray. All right, we've finished the design portion of this project. From here, it's time to go down to the machine. The actual machining video for the drop tray is your next step. See you there.